Viewing and editing corridor sections. This tutorial demonstrates how to edit a corridor in section. Exercise 1, Viewing corridor sections. In this exercise, you will view how a corridor assembly is applied at various stations along a baseline alignment. The View/Edit corridor section tools are useful for inspecting how the corridor assemblies interact with other objects in the corridor model. View a corridor in section. Open corridor 4A.dwg. The drawing contains an assembly, profile view, and corridor model. Each object is displayed in a separate viewport. The viewport that contains the assembly is active. Click Modify tab Design Panel Corridor. Click Corridor tab Modify Corridor Sections Panel Section Editor. On the Section Editor tab, on the Station Selection panel, in the Select a Station list, select 0 plus 0 0.00. A cross-section of the corridor at the starting station is displayed. The elevations and offsets are displayed on the grid axis. The cross-section view contains the assembly, as well as the other adjacent objects. At the current station, the offset alignments are represented by vertical green lines, and the existing ground surface is represented by the horizontal red line. The vertical red line in the center of the grid represents the assembly baseline. Profile intersections with the baseline are indicated by markers. Use the tools on the Section Editor tab to view the corridor sections at each corridor station. Click Go to Previous Station and go to Next Station, or select stations from the Select a Station list. Notice that as each station is displayed on the grid, its location in the plan and profile viewports is identified by a perpendicular line. Experiment with the zoom modes. Zoom into the lane on the right-hand side of the assembly. Click Go to Next Station. Notice that the view zooms back out to the grid extents. There are 3 zoom modes in the View/Edit corridor section tools. These modes control the behavior of the grid when you navigate to another station. Zoom to Extents view zooms out to the extents of the assembly, plus the view scale factor. This is the default zoom mode. Zoom to an offset and elevation view remains zoomed in on the current offset and elevation. As you navigate to other sections, the current offset and elevation remains at the center of the viewport. Zoom to a subassembly view remains zoomed in on a selected subassembly. As you navigate to other sections, the selected subassembly remains at the center of the viewport. In the Select a Station list, select 3 plus 0 0.00. On the View Tools panel, click Zoom to Subassembly. In the Pick Subassembly dialog box, select Daylight. Click OK. The view zooms into the Daylight subassembly at station 3 plus 0 0.00. Notice the shape, elevation, and offset of the subassembly. In the Select a Station list, select 9 plus 0 0.00. The view zooms into the Daylight subassembly at station 9 plus 0 0.00. Notice that the shape, elevation, and offset of the subassembly is quite different from station 3 plus 0 0.00. The subassembly remains at the center of the grid and at the same zoom factor as you navigate to other stations. On the View Tools panel, click Zoom to an offset and elevation. Click Go to Next Station several times. Notice that the offset and elevation values that are displayed on the grid axis do not change. The shape of the Daylight subassembly changes to reflect how it ties into the existing ground surface. On the View Tools panel, click Zoom to Extents. Click Go to Next Station. The view zooms back out to the extents of the assembly. Exercise 2, Editing Corridor Sections. In this exercise, you will edit the parameters at several corridor sections. Modify subassembly properties for a single station. Note: This exercise uses corridor 4A.dwg from the previous exercise. On the station selection panel, in the Select a Station list, select 7 plus 75.00. On the View Tools panel, click Zoom to Subassembly. In the Pick Subassembly dialog box, select Lane. Click OK. On the Corridor Edit Tools panel, toolbar, click Parameter Editor. In the Corridor Parameters dialog box, in the Assembly, Tree, under Group, expand Lane. Notice that identical values are displayed in the Design Value and Value columns. The Design Value column displays the value that was specified when the subassembly was added to the assembly. The Value column displays the actual value of the subassembly at the current station. In the following steps, you will override the design value at the current station, and then examine the results. Change the width value to 36.0000. Notice that the Override checkbox is automatically selected, which indicates that the design value has been overridden at this station. Click Go to Next Station several times. Notice that for the other stations, the width value is 12.000. The lane subassembly that is displayed in the section view updates in width to reflect the width at the current station. On the Station Selection panel, in the Select a Station list, select 7 plus 75.00. In the Corridor Parameters dialog box, in the Assembly, Tree, under Group, under Lane, in the Width row, clear the Override checkbox. The Value column displays the same value as the Design Value column. Modify subassembly properties for a range of stations. On the View Tools panel, click Zoom to Extents. On the Station Selection panel, in the Select a Station list, select 4 plus 50.00. Notice that the road is in a shallow cut on one side and deep cut on the other. The criteria set for the daylight subassembly caused it to use a 6:1 slope on the left side, and a 4:1 slope on the right side. Also notice the super elevation transition of the road. At station 4 plus 50.00, the lanes are relatively flat. Note: for more information about super elevation, see the Applying Super Elevation to an Alignment tutorial. On the Station Selection panel, in the Select a Station list, select 7 plus 75.00. Notice the super elevation transition at this station. Using the center line pivot option on the depressed median subassembly causes the lanes and shoulders to super elevate about a point above the center line ditch. A straight edge laid against the lane surfaces would pass through the profile grade point. In the Corridor Parameters dialog box, in the Assembly, Tree, under Group, expand Median. Notice that the center line pivot design value is set to pivot about center line. In the Center Line Pivot row, click the value cell. Select Pivot About Inside Edge of Traveled Way. On the Corridor Edit Tools panel, click Apply to a Station Range. In the Apply to a Range of Stations dialog box, notice that Start Station is 7 plus 75.00, which is the current station. For End Station, enter 11 plus 00.00. Click OK. On the Corridor Edit Tools panel, click Update Corridor to update the corridor model. View the corridor section at station 7 plus 75.00. Notice that the profile grade is held at the inside edges of traveled ways and the lanes and shoulders pivot about this point.